Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
This is the third problem in the fifth homework for statics, and here we have 1, 2, 3 ceiling points and a point where basically strings from those ceiling points converge, point D, and at that point there is a weight of 156 pounds hanging downwards. So we have to basically work off the free body of point D. So there are forces going downwards, that's the weight, and there are 3 forces going in dA, dC, and dB directions. So let's find out what those directions are. So dA, so A is 800 and convert it into columns. B is 762, so 762, make it into a column vector, and C is -2, 4, 8, and make that into a column vector. And D is 532, 532, and make that into a column vector. So now all all 4 points are shown. Weight is not shown. The weight is 0, 0, minus 156, and make that into a column vector. So the resulting force is actually the negative of the weight. So I'm going to convert that into negative weight, and that's our resulting force of the forces of the tensions added together. So the first force direction is dA. dA is A minus D. The second force is dB, and that is D minus B. And the third force is dC, and that is equal to D minus C. And the unit directions for these are UDA is dA divided by norm dA, and dB is the same. dB is dB divided by norm dB, and dC is the same, dC divided by norm dC. So now we have the direction vector, the unit direction vectors UDA, UDB, and UDC for the forces of tension along these cables. Now we need to create a matrix with these direction vectors. The matrix is called U vector, and that is going to be UDA, UDB, and UDC. And let's look at this vector, this matrix. It looks pretty uniform. There is a 0 here. That shouldn't cause a problem. There's a 0 there because D and B are at the same level. Okay, so having seen that, what we need is the FR, and we need to get the inverse of this matrix. Let's try to see if this inverse even exists. And this inverse it exists, so we can use that times FR is let's call this the T vector, and that should create our answers for us. And these are our answers. we need the magnitude so we can dispense with the negative signs. So 382. Why are there negative signs? .4821. Well, math doesn't lie, so let's hope things are kosher. 0997 and 493.1879. They are correct. I wonder why there are negative signs. Maybe because there's a string actually below the point D, so it's actually pulling it downwards. It's actually adding to the weight of this, and so that's why this string is actually pulling it downwards. So that's kind of in the negative direction. So if it's pulling it downward, it needs to be pushing it up. So this string is not taut, it's actually that's why this is weird configuration. Alright, so, but we got the answer correct, so see you next time.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.